My name's Corey, I'm one of the advocates here at Unity, and we're here to kind of help you make better games, better products, understand the API and the pipelines that are available, and today we're going to be running through a demo as well using the 6.4 beta. So because of this, just be aware if anything does happen unexpected, we're running in beta, but this is completely accessible to yourselves as well. So we are going to be in the engine for the majority of this. I just got some housework to go through at the start, and we're going to be looking at how you can remove that pesky domain reload. So every time you compile your code and you're going to see domain reload, there is a kind of a small fix for this. And it depends if you're working in the scene or you're working on code predominantly. And we're going to look at the project auditor, one snapshot, one of my favorite features added to Unity over the past year. It basically allows you to understand your project files and get a holistic view to see exactly where areas may be cause for concern when it comes to frame rate, and you don't have any access to any debugging tools, for example. Like, it really provides you and holds your hand through it. And then we're going to identify some memory leaks that I have artificially injected into this application, and we'll walk through this together to try to see how we can improve it. But before we get into that, I do just want to mention that the engine can scale to large, ambitious projects. And here we can see publisher Bohemia Interactive developed the game Silica. This is a HDRP title available on the Steam just now, and it's been pretty well critically acclaimed. This is part of the production verification process as well at Unity, where we're able to see exactly where we're able to see what projects where we're able to integrate more features into the pipeline and partner with talented studios to see what they need. How can we empower them as much? Here's a new Unity build, and we'll be able to see what feedback they have to put back into the engine so everyone in the community can see it. And you can see this is the new roadmap. So this was also announced at Unite last year in Barcelona, but also at the GDC live stream. Feel free to check it out. It was out on Friday. We kind of go over this in much more detail, what the differences are between the LTS versions. But we are on 6.3 LTS, and today we're going to be taking a look at the 6.4 beta specifically. Unity 6.7 LTS looks quite incredible with the core CLR as well. So a little bit of housekeeping. Project auditor, what is it? Where do you use it? Well, it's a snapshot of your project through code using Roslyn analyzers, and also using the textures and assets and build properties in your engine. So you're able to fire this off as well in your CI/CD pipeline. So if you want to understand whereabouts in your project, I'm going to punch that up a little bit. If you want to run this after every build or major release or milestone that you and your team have, then you can do this, and then you can compare performance over time. To run this, in case you weren't aware as well, we do have a batch mode in Unity Editor, so you can actually just fire a command and you can run it with a headless version of the editor, so you can actually execute a report. And the report generated is completely in JSON format, so you can analyze it in other tools as well if you like to, as part of your CI/CD pipeline. So the profiling workflow as well, the profiler has been out for a long time now. It's gradually getting updates, and we actually have the AI assistant tools available, which was demonstrated at Unite. There is a flowchart available in the ebook, and again, all the resources are available at the end in a QR code, so you can just scan that. It's a short survey. Feel free to fill it out and provide feedback to the team on features you're enjoying, some areas of concern you have, and we'll relay it back to the dev teams. But there is a flowchart here, and you can understand what aspect of the profile you're going to look at. Is it memory? Is it graphics? Is it your CPU that's being bottlenecked? And you can flow through this chart yourself, and you can see, narrow down more specifically about where your issues are. So without further ado, we're just going to jump into the demo we have here. Gosh, you can't see that so well, so I'm going to try punch in as much as we can. So the theme of this demo is pollution. Code pollution, project pollution through large textures and asset files that we've forgotten about perhaps when we developed our MVP. Maybe we participated in a game jam and now we're about to release to a publisher. What we have is pollution in the scene. So we have just some barrels here that are leaking out some kind of glowing cylinders here. But we can see that they're being destroyed after a period of time as well. This is all artificially injected into the project, and it will be available as well at some point soon, so you can download it yourself and understand exactly where a memory leak is. But again, this is a leak. We have a memory leak in our game. Let's try to identify where it is using the tools in Unity 6. Before I do that though, I do want to showcase the domain reload, and I just want to emphasize that this is something that we can adjust in the project settings. If we just go up to edit and preferences, edit project settings. Under editor, if we scroll down here, we're going to see an option that's going to allow us to enter play mode settings. We have domain reload for domain and scene. So the domain is going to be the back end, where your DLLs are basically being referenced by the Unity editor. Every time you make an adjustment to your code, it's going to have to recompile these, so then the editor can actually process your changes. But if we want to say do not load the domain and we just want to reload the scene, and we click play here, what we're going to see is the scene runs much quicker. We can see that instantly. But you'll notice in the corner of the screen, we do have a warning. And this warning was put in by me just to emphasize the issue, and we'll look exactly how to remove this warning. And it's because we're using a static variable. Now, if the domain hasn't reloaded and we have a static assignment, if you're using a singleton design pattern, for example, then we're going to have to make sure that that value is reset appropriately between each session of running play in the editor. So if we double click on this, we're going to load up into our instance of VS here. And all we're doing is setting the game state to true or false based on the amount of times we've played it. So if we click play again, you'll notice total runs is now 3. So if we click stop, we're in the game, everything looks good, but the total runs are now 4. So this means all the static variables are being assigned and their references in memory aren't even being cleared, never mind the domain reload. So in order to fix this, what you have to do is run the runtime initialize on load method. This is a placeholder you put above your functions that you want to call at before scene load, and it will allow you to use your static references, but ensure that the state is being reset every time before you load your scene. So something to look into there. It can definitely speed up your performance when editing and you're reviewing scene changes. So you're designing a level, you're not manipulating code that much, but perhaps that you have a small system that you can actually work with, and you'll be able to work through here. So if I clear that, let's just click play. And we'll see now we've got total runs back at 1, because every time the scene's loaded and we click play, it's being reset. So on the left-hand side here, for any keen eye, apologies, I'm going to try punch this in so you can see it in a bit more detail. So those with the keen eye will notice the statistics window has been updated. Let's try to move this across a bit because I'm cautious you can't see that. So we have the hardware, scene, and memory. These are available within the stats window in Unity 6.4 beta. We also have the Open Profiler widget down here at the bottom, which allows you to get access to the profilers straight away. So one of the areas I'm actually interested in looking here, I'm not seeing that many triangles, I'm not seeing too many vertices, draw calls are really low. Memory looks pretty good just now, but what I am noticing something here is streaming texture memory versus non-streaming. We're looking at 10.4% streaming texture memory and 89.6% non-streaming. Ideally, this is due to bitmaps, and ideally you want to have these streaming on a scene like this if we're using large resolution textures. And we're going to dive into that, and I'll explain a little bit more what that means if you're unsure. So the benefit of having the Open Profiler button here is it's instantly going to start recording our session straight from the area that we were just playing in the scene. Before I jump into analyzing this, what we're going to do is just stop the session here. And I'm going to minimize the profiler and actually jump into the project auditor, and we can look at this in a second. Because when we jump into a project, we don't always understand exactly where the areas of concern are, and that is where the project auditor comes into. So if you go up to Window, Analysis, Project Auditor, we can see a summary page at the top. Hopefully that looks good for you all. We can see we have code issues, we have asset issues, and we have only 14 project settings issues. We can see here there are top 10 issues, however. We have a boxing allocation, we have Unity Engine object name, object instantiation. So this snapshot has been looking at our entire project as including the code base itself, the assets, the textures, the audio, any other features we have inside of our Unity project that the engine can read. We're going to be able to kind of digest this, and without having to understand exactly what these are, we can expand each option. It's going to provide us a detailed information about the object.name property, and then recommendation, because it's not best practice to really reference objects by object.name. Perhaps we should be using even a scriptable object at that point. One thing I am interested in, though, is we saw that memory streaming only about 10 to 80%. We kind of want to neutralize that a bit. And what I am seeing here is we have texture bitmaps is not enabled. So if we go over to more details here on the top 10 issues, it's automatically highlighted all of the textures here that we have in our project where bitmaps are not enabled. We can quite literally click on quick fix here in the corner. It will, I would say automatically, but it is actually going to enable bitmaps for all these textures that we have in our project. So we no longer have to go through manually and allocate each one of them, or even identify the location of potentially a high resolution texture that we forgot is existing in the project. So if I double click on, for example, this texture 2D bark bitmap, I've clicked on it here, and on the right hand side, I'll punch this up a bit. What we can see is that the generate bitmap option is now checked. Now, one thing I am aware, though, is if we want bitmap streaming to occur, we're going to have to enable another checkbox. Now, for those unsure on what a bitmap is, firstly, you can consider it as a level of detail system, but for textures. It's a process in which the texture resolution is going to be halved about 5 times. So we start at 256 by 256 texture, and then we go down to 128 and 128. And why do we have this gradual reduction in resolution for a bitmap? Is because rather than storing everything in a 1080p by 1080p, based on the distance that we are to the object, the text resolution will drop down. So it's very akin to that of a level of detail system used for 3D models, but a bitmap is for the texture equivalent. So if we're further away, it's going to put in a lower resolution. But the thing about bitmaps is if you don't have the streaming enabled, then all of the bitmaps are going to be loaded onto the GPU memory. So that means you have potentially 5 different textures for the same object in memory. It's good for preventing certain artifacts and graphics, but it's still going to be kind of lingering in your memory. And this isn't going to be that efficient if you have large textures, resolutions, and large open world environments. So by enabling the streaming option, we instead call from memory to the GPU memory just the textures and resources we need. So we don't need to dive in and worry too much about the size of the initial bitmap that we're using. So under the bitmap option, we do have stream bitmap levels. So I am aware that all of these bitmaps are in a folder here called art environment. So I'm going to select them all. I'm going to disable our skybox, and I think there's an asset there. So if I go over here, we're going to select generate bitmap, and we're going to select this big option here, stream bitmap levels. I'll then apply this to these, and we'll see it in real time. These are all PNG graphics. And we have one more under here, and I am going to do this manually just so you can see again. It's not an intense process to convert your bitmaps, even for an environment with a fair amount of textures. So bitmap limits, stream bitmap levels, great. So those ones are actually already enabled. Now, if we go back into our project auditor, let's just take a little closer look at some more of the assets we have, and then we'll play and we'll see if there's a difference there in the percentages. We can see all of our textures here. We can see that they're automatically compressed. If they weren't compressed, we would see that here, uncompressed. Now, ideally, we want everything to be compressed with something like ATSC. ATSC compression is inside of the engine as well. It has the best balance for fidelity to memory ratio. So ATST if you're definitely working on an on-tile memory. If we take a quick look here, though, we can see that one's at 16 and it's uncompressed. It's 2K resolution, so really we want to go investigate this more to see why is this resolution so big and it's not compressed. If I go over to our code examples now, real quick. Let's make sure, yep, cool. So what? Short in time, so I'm just cautious here. What I'm going to do is I'm actually going to play this scene, and we're going to have a look at this. So now you can see we're about 41 to 55. So that went from 10% to 55%. If we went through and enabled bitmap streaming for all the options as well, all the other textures that perhaps were missed out there, we would probably see that kind of push towards like a 90 to 10% ratio. If we go up to edit and project settings, what we're actually going to find as well is we need to ensure that bitmap streaming is enabled within our URP. So the only other checkbox you need to enable is to ensure that bitmap streaming is enabled. And this is, if we go up to edit, project settings, let's click on our graphics, quality, sorry, PC Universal Render Pipeline asset. And load crossfades. actually, it must already be enabled. Let's have a look. MIP map streaming. Okay, I may come back to this in a second, because there's just a little chat box you need to enable, and it's not in that. Light map streaming enabled. Let's have a look. Okay, right. I'm gonna revisit where that location is, because usually it appears somewhere around here. But there's just a tech chat box. It basically means that the MIP maps can be streamed to the GPU. Are you seeing it here? Is it right here? Was it on the other one? Okay, cool. Thank you for pointing that out. But we have it already checkboxed, so that's probably why it didn't appear as well. The last thing I want to go over here, as we've got maybe 10 minutes or so, is we're going to take a look at the profile and try identify this memory leak. So just so you understand how this project is set up, we have the memory leak pollution. I have just provided some examples that the project auditor is using as a rule set. So the project auditor is a snapshot of our project, but there's thousands of different rule sets that the engineers have put in with best practices. Some of these include anonymous function, static destroy, how to instantiate an object, and we might have something here we can be pointed towards by taking a look closer at the profiler. So this is the profiler in Unity 6.4. The key changes include we have the CPU usage and memory exclusively selected here, and highlights. I haven't enabled the other ones for brevity, as we're going to be trying to understand why was our, we're going to try isolate and see if there is an issue in our memory here. Now, when you select on the there is further information on the CPU profiling. There's a really good talk on the Unity channel by Peter Hall. He works on the performance and optimization team and is kind of responsible for this. So I do recommend checking out that talk for an in-depth view on CPU optimization. But specifically here, on our memory, I can see we're at 400 material counts, and we can see we have our total used memory, and I've just enabled material count. You can also use garbage collection used memory. They're kind of the two I tick in projects just to make sure where could a potential memory leak issue be if there is one. And we can see we have 400, and then it goes up to 418. Now, what's weird is this project doesn't actually have any code that's instantiating an object and then not destroying it within 5 or 10 seconds. So I think we have a memory leak here because we're seeing that the material count is growing in size, but we're destroying the objects, and there's nothing else in the scene that I know is there. So if we click on the memory profiler, here we can see at the bottom we have memory usage on device, allocated memory distribution, and top objects categories. This window is really quite efficient for getting an understanding of what your memory looks like on your system at this point in time. Remember, if we're running this with the editor open, there's going to be a lot of overhead there. So if you have something like Chrome or you've got Photoshop on in the background, be aware that this will impact this. But if we click on Open Memory Profiler here, we can actually create a snapshot of this system in real time as it goes. Now, because I am not running the editor just now, and I don't actually want to cause a memory leak, what I'm going to do is just load up one I made earlier. And the best practice for this is to take a snapshot of your memory, again, along with the project auditor, before you start making migrational changes into production. Or maybe you have a new epic or a new milestone you and your team have set. Take a snapshot of the memory, so if something does go wrong in the near future, you can always go back and just visualize on the memory profiler, or the project auditor, just without even having to go through the code, load up the project. Speeds up time on your development. And to note there, the project auditor was actually developed by the consultants at Unity to understand holistically what the project looks like, how many assets are in there, how much is there is code, and then they can try work from there. It's a highly efficient pipeline to work through. So previously, we just took a look at our profiler memory, and we noticed that there was texture count, material count kept increasing. So we can now look at this snapshot of our system within the editor, and I know this is small, but if I scroll down here, we're going to see material. There's 566 objects. So I'm going to scroll down here, and I can see that this looks pretty good. I'm not seeing much repeated textures. Everything looks quite standard until I get further down to the bottom, and I should see a lot of toxic material instances that are no longer being managed by the garbage collector. So the .NET compiler, the .NET runtime will complete garbage collection. We know this in C#. It will complete garbage collection. However, in Unity specifically at this time, we can see if I load up our code under our instantiated object, now I know my prefab garbage is using is the object being instantiated. So if I click on our code here, instantiated bad example, I've called it, we can see that we have indeed spawned an object. It's going to last 15 seconds, but we have unallocated it from any sort of accessible memory location because we're just creating a component renderer and assigning it a color just for this example. But this means that the instantiated prefab has no reference to this generated material. So every time it's being created, it's being allocated in memory. The garbage collector doesn't know it exists. You don't know it exists technically. So that's the leak. So we've spotted where the leak is, and to show you the example on actually, well, how do we avoid something like this in the future? One would be to quite simply don't manually allocate your materials at the top, so you have a reference to that in memory all the time, because you're going to have references to this public material array that could have multiple colors. But the best way to avoid stuff like this is to actually create pools, follow best design practices, and use the onDestroy function to clear pooling. So then the prefab is being managed by the object pool, and any object inside of this pool is a prefab in itself that you can actually access all of the components for. So don't randomly instantiate materials and properties on objects that you're not sure where it's being allocated to. If we load up the project auditor again, I go up to analysis and look at our project auditor. We can see under code, I'm going to reverse the severity here, and I can scroll down on the right-hand side here, and let's have a look and see if we can locate the bad example. So here we have Unity engine.renderer material usage. Now that's exactly the issue that we just identified that sprung the leak, but the auditor actually already picked this up. So if you understand that you can run the auditor at the start of your project, you don't even need to bother going into the code, the memory, understanding where this issue was, because the auditor at the very start took a snapshot of your project and actually recommended, well, we can see exactly what it recommended. Under the instantiate bad example, we can see the render material property creates a unique copy of the renderer's material. This breaks draw call batching and results in a higher performance draw calls, impacting performance. The reality is as well, because we're also being detected by the instantiation is also being detected here as an issue. So with this, the project auditor can actually save you a lot of time. We've just stepped through the process to identify where the leak is, but if we stepped through each of these issues that the auditor has collected on our project, we would have avoided that memory leak entirely. Cool, thank you. Well, that's actually on time. So with that said, we've taken a look at the memory leaks, and just to understand as a closing thing towards that, yes, the garbage collector does a lot of work. You probably won't find a memory leak if you're architecting your code okay. It's not that common, but it's definitely happened when you're working on your MVP, your game jam, your short-term project that expands over into production. You might have new members of the team get onboarded just to try something out, and that that test code is actually in production. And you're expecting the loading of assets and instantiation to grow, you're expecting your project to scale, but you can't recover from memory leaks. And with that said, I'm going to stop here, and there's some advocacy assets and samples here from Kajiro, which is a fellow member of the team, exploring web GPU. And then Esteban is about to give a run through over the multiplayer third-person gameplay template later on this session. Yeah, sure, I'm open to questions at this point, absolutely. Feel free to ask anything here. We'll be downstairs at the booth as well, big Unity banner, happy to show you demos.